Hello students, I am Rutuja Patil, a faculty from KLBCA College Nippani. Welcome to NMS class. Today we will see regarding the secant method. In my previous videos, I talked regarding and we have solved about the problems on the bisection method and regular falsi method. So in this video, we will see the problems and the derivations and the formulas on the secant method. See, we have used the bisection method and the regular falsi method for what purpose? To finding the approximate root of any given equation, right? Whether that may be an algebraic equation or that may be a transcendental equation, right? So same thing here also we are going to use the secant method for the same purpose. This secant method is also called as, that is, method of chords. Okay, this second method is also called as method of chords. Now first me just represent this in the geometrical diagram diagram. Okay, so this is my y-axis and this is my x-axis. Okay, any given equation I am representing in this graph. So this is a chord, one line. This is a line which is nothing but the line is drawn based upon some equation f of x. Okay, that this equation is nothing but our y, that is f of x, that is nothing but f of x is equals to 0 equation. And then first approximate root value, say x naught. So when I put this x naught value in the equation, given equation f of x, so that whatever value I'll get, so that value meets the this equation line at this point. Okay, now if I draw another chord at this point, see if I draw another line at this point, okay, so I get like this. Now this point, how I'll get, that is by substituting this x naught in the formula and I'll get there x1. So when I get the x1, when I substitute the value of this x1 in this equation, I'll get this point. Okay. So now again, if I draw a line from this point, so that is what we have here. So if I draw another line at this point, so that is what we get here. Okay, so this is our x2 and here we will get another value for root, and if we draw any line from this point, so that means at this point, assume these are approximate values. Okay, these are just the approximate values, so that is at this point. Now, whatever value we have got x naught, when I substitute in this equation, so I get this point, that is nothing but my f of x, that is the value of y we got, right? So that is a x naught f of x naught coordinates I can write for this, and this point if I consider b, that is x value at this point is x coordinate value is x1 and y coordinate value is f of x1. At this point x coordinate value is x2 and y is nothing but f of x2. At this point, if I consider it as a d, x coordinate value is x3 and y coordinate value will be f of x3. So this is my 0 and this is x, right? Y coordinate, right? So these are the values when I get for f naught, f x1, x2, x3. But actual root lies where? The actual root lies at this point. You can say actual root lies at this point. For some equation, we may arrive at getting the nearest value. We will get the nearest value, but not the exact value. Very rare cases we get this. But using these methods highly, 99% we don't get the exact values. We will try to arrive to get the nearest value for x, that is the nearest value for this equation, nearest root value for that equation. Okay, Now, so how, let me derive the equation for this method. So first, so what we will take, we are going to take this x naught and x1, these two values x naught and x1 as the initial limits of that interval. Okay, in previous method we had considered a and b values, right? So like that, let this x naught and x1 as the initial limits of the interval. So taking this x naught and x1 as the initial values, or we can say initial limits of the interval. Okay, so now how can we write the equation of the chord joining these two, that is x naught and x1. This is a chord which is joining this x naught and x1, right? So we, in the mathematics, we have that formula, that is the line joining the 2 points x naught and x1. That is what it is, nothing but y minus y1 is equals to y1 minus y naught divided by x1 minus x naught into x minus x1. Okay, so that is what you have studied in the previous year maths classes, right? So now by using that, I can write the equation of the chord joining these 2 points as y minus f of x1, y minus f of x1 is equals to f of x1 minus f of x naught divided by x1 minus x naught into x minus x naught. See how we get this? How we get this? Because we have the equation, line joining uh, the chord joining the two points. Mathematics, we have that equation, right? So if you are not remembering, just let me tell you. So we have one equation in mathematics, that is the equation of the line joining the points. That is, if you take point A as x naught y naught and point B as x1 y1, so what is the equation we have is y minus y1 is equals to y1 minus y naught divided by x1 minus x naught and x minus x1. So since we know what is the y is 0, that we are going to, because f equation is f of x is nothing but 0, and that equation is y is equals to f of x, and we have f of x is equals to 0, means the y value is 0, that is y value is 0. That is what we are going to substitute. So see, so in this, to form this equation, so what I have considered, that is my y1 is nothing but this f of x1, and y remains as it is. Why? Because y is 0 only, and that y is nothing but, we have to consider f of x is equals to y is there, no? So according to this equation, that is this y. Now these are my 2 points a and b. A and b are nothing but 2 points, like 2 points joining this chord. Now if I put this in equation, what is my y1? Y1 is nothing but this f of x1, that is what we have written, minus y naught. Y naught is this one, f of x naught divided by x1. Yes, here also we have the point x1 only, minus x naught, and x is another variable, x minus x naught. Okay, so x minus x naught. Now next, sorry, this is x minus x1. Now next, now then the abscissa of the point where it crosses x-axis, that is what, where it crosses this x-axis is y, that is a 0, right? So we are finding the value of x at this point, y value will be 0 only. So let just put y is equals to 0. So that is, just put y is equals to 0, and then if you arrange the terms, and then you will get x is equals to x naught f of x1 minus x1 f of x naught divided by f of x1 minus f of x naught. Okay, so this is what is the required approximate root formula. Okay, so here we need to use this, so which is an approximation to the root. Okay, which is an approximation to the root. Now if I put it in the general form, see, I know x naught is my first approximation. Now if I want to find the next approximation, that will be my x1, right? Now in the general form, that is the general formula, if we derive the general formula for successive the general formula for successive approximation of the root is nothing but xn plus 1, that is the next value of n, x previous xn minus 1 f of xn x1 we know, right? This is x2, so f of xn minus xn f of xn minus 1 divided by f of x1 minus f of x naught. So this is the, sorry, f of xn, x naught is nothing but f of n minus 1. So this is the general formula that we need to use, and where this n is greater than or equals to 1. So this formula we need to use to find the successive approximations of the root by using this method. Okay. So this method, we can also say that it's an improvement over the regular policy. Why? Because here we need not to do any f of a into f of b is less than 0. No, it's not necessarily every time we need not to do that. Okay, so this is regarding the secant method theory part. That is what we have derived this formula, and we need to use this formula to find the approximate roots of the given equation. So iterative method it is. This method is an iterative method. It's not like the bisection method that we have done, or the regular. It's the improvement over the regular policy method. So I'll take one problem so it will be more clear for you if we solve the problems. Okay, so let us take first example on this, that is find the real root find the real root of find the real root of the equation x cube minus 5x plus 1 x cube minus 5x plus 1 equals to 0 using secant method, then corrected to 3 decimal places, corrected to 3 decimal places. Okay. Okay, first thing is here we need to find the x naught and x1. That is what how we have done for the previous method, bisection methods. That is, we have to find the interval values, right? We have to find the interval values, that is a and b. So here we have given the name for a and b as x naught and x1. So the same procedure we need to apply here. So let f of x is nothing but the given equation. Yes, this equation is already in the f of x is equals to 0 format. So take this as it is, x cube minus 5x plus 1. Then substitute some random values. So f of 0, if I do, f of 0 is 0 to the power 3 minus 5 into 0 plus 1. So 5 into 0 is 0, 0 minus 0 is 0 plus 1 is 1. And then, so f of 1 is 1 cube minus 5 into 1 plus 1. So what we get for this, if you substitute the value 1 cube is 1, minus 5 into 1, minus 5 into 1 is minus 5, then plus 1. 1 minus 5 is minus 4 plus 1 is minus 3. So this is minus 3. So one value is positive, one is negative. So if you multiply these two, you will get a value which is negative and it will be less than 0, right? So therefore the root lies where? In 0 comma 1. Okay, so by this what we can do, we can take our x naught value as 0, okay, and x1 value as 1. And we also know what is f of x naught. When we had substituted this x naught 0 value in this, what we have got, that is 1. And when we have substituted x1, that is 1 in this, how much we have got the value, that is 3, that is minus 3, right? Now by using the secant method, what is the formula we have to find the next x2, x3, x4? We have to go on finding this, right? See, they have told correct up to 3 decimal places. So until we get the after the decimal point 3 digits as the same, we have to go on iterating through these steps. Now, say by using secant method, by using the secant method, what we have the formula, that is general formula. First write it down. Xn plus 1 is equals to xn minus 1 f of xn minus xn f of xn minus 1 divided by f of xn minus f of xn minus 1. So this is the general formula. So we have derived, right? We know this. Now using this, we already know x naught and x1. So what we need to find out is, we need to find out x2. Now derive the formula for that. x2 in the sense I have put in place of xn as 1. So n always starts from 1, right? So 1, 2, 3, like this. So put 1 x n is equals to 1 in this. So when I put n is equals to 1 in this, how much I got? 1 plus 1, that is 2. Yes. So now n is 1. Substitute 1 in this. 1 minus 1 is 0. That is x naught. Now f of n is 1. So f of x1. Okay. And then minus xn. That is x. N is 1. 1. F of n minus 1. N is 1. So 1 minus 1 is f naught. Similarly, what is fn? That is f of 1 here, x1, then minus f of x naught, right? Okay. Now substitute the values. X naught value we know 0. 0 into f of x1 is minus 3 minus x1 is 1 into f of x naught is 1 divided by f of x1 is minus 3 minus f of x naught is 1. Okay, so find out this. 0 into minus 3 is 0 only. So minus 1 into 1 is 1 into 1 is 1. 1 divided by 1 divided by 4. 1 divided by 4 is nothing but 0.25. 0.25. So that is our what? X2 value. Now how much we got the value for X2? The value for X2 is 0.25. Now next, what we need to find out? F of X2, right? So f of x2, that is f of 0.25, that is f of 0.25. Now substitute here f of 0.25 where in this equation, that is in this equation, that is 0.25 to the power 3 minus 5 into 0.25 plus 1. Okay, so if we do 0.25 to the power 3 minus 5 into 0.25 plus 1, so we get here minus 0.234375, right? So that is what? Minus 0.234375. Now write down all those whatever we have got. X2 how much we got? That is 0.25. Then f of x2 how much we got? What we have calculated is minus 0.234375. This is just a x2. X2 is 0.25, x1 is 1. Still, it is not correct up to 3 decimal places. Again, what we need to do? We need to find out x3, next approximate root value. So derive the formula for x3. To find here, to get here t, what I need to do? I have to substitute here 2. So in place of n, I have to substitute there what? 2, right? So 2 minus 1 is 1, that is x1. Then f of 2, that is f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. Okay, so now substitute the corresponding values. X1 how much we have here? That is 1. So 1 into f of x2 we have found out is this much, that is minus 0.234375 minus x2 we have is 0.25 into f of x1 how much we have? F of x1 is minus 3. It is minus 3. Okay, so divided by f of x2 is this one. Minus f of x1 is minus 3. Alright, now substitute the values in this and find the values of x3, right? So when you substitute, it's nothing but 1 into minus 0.234375 minus 0.25 into minus 3 divided by minus 0.234375 plus 3. Right, so what is the value of x3 we get here? X3 is nothing but 0.186441. Now we have the value of x3. Substitute this value of x3 in this equation and find the f of x3. Find the f of x3. So whatever x3 we are having here, we need to substitute this value of x3 in this equation, right? Now substitute x3 in this equation, that is 0.186441 to the power 3 minus 5 into 0.186441 plus 1. Okay, so how much is the f of x3 we get here? We get the f of x3 value as 0.074276. This is f of x3. Okay, see, still check here. If x2 is how much? 0.25, x3 is 0.07 something. Okay, but what they have told is correct up to 3 decimal places. Still one decimal place is also not same. After the decimal point you can check. So what is the value of x3 and f of x3? Again we need to substitute those values and we have to carry out the further steps because still we have not got the answer, right? So now again, so whatever we have got here, x2 how much we got? x2 we had got 0.25. Then f of x2 we had got minus 0.234375. Similarly, how much is the x3 we had got? Just now we got x3 0.186441. Then f of x3 we got 0.074276, right? Now next step is, it's not over, we have to find the x4 still, right? So what is the formula? That is x2 f of x3 minus x3 f of x2 divided by f of x3 minus f of x2. Okay, so substitute the corresponding values. x2 value is 0.25, so 0.25 is the x2 value into f of x3 is this one 0.074276 minus x3 is this one 0.186441 into f of x2 is minus 0.234375, right? So divided by f of x3 0.074276 minus f of x2 minus 0.234375. All right. Now we need to calculate this. We need to calculate this and we should get the x4 value. This is nothing but x4, right? Okay, just calculate this. 0.25 into 0.074276 minus 0.186441 into minus, so this is x3 we have written, yeah, into minus 0.234375 divided by 0.074276 minus of minus 0.234375. Okay, so the next value of x, that is x4, how much we get here? 0.201736. Okay, so let me write that 0.201736. Now just substitute this and find the f of x4 in the equation. What is the equation? X cube, right? That is 0.201736 cube minus 5 into 0.201736 plus 1. So just do this. That is 0.201736 to the power 3 minus 5 into 0.20136 plus 1. Yes, so if I do, how much I'm getting f of x4 into 10 to the power minus 4. Minus 4 into 6, 9 something into 10 to the power minus 4. So what I need to do, I can't keep my answer in this format. So I need to transfer this decimal point 7, sorry, not 7, 4 positions towards the left, right? So if I do that, what I'll get? 0.000469. Okay, so this is my f of x4. Okay, now we have this as x4 and this is our f of x4. So it is not over still. Again you check here, x4 0.201. x3 is 0.186. So even single digit is also not the same after the decimal. Okay, so again we need to carry out the steps here. Now to find the x5, what is the formula? So 2, that is xn minus 1, right? So it is x3 f of x4 minus x4 f of x3 divided by f of x4 minus f of x3. Okay, now whatever values we have calculated, just substitute those values. What is x3? That is this one, right? So 0.18641 into f of x4 we just found out 0.000469 minus what is x4? This value 0.201736 into how much is f of x3? That is this value, right? So 0.074276 whole divided by x of x4, this one 0.000469 minus f of x3, this value 0.07427. So calculate this, then we will get the x5 value, right? So I just do the calculation for this. 0.186441 into this value 0.000649 minus 0.201736 into 0.074276, okay, divided by 0.000469 minus 0.074276. Sorry, once again I'll do. So 0.186441 into 0. So this is minus, right? So this is minus x4. F of x4 is, here we get this as a minus. So minus 0.000469 minus 0.201736 into 0.74276 and divided by minus 0.000469 minus 0.074276. Okay. So if we do the calculation, so we should get the x5 as 0.20164. Okay. Now here you can check what is the value of x5 we got. That is 0.20164. And x4 what we have 0.201736. What they have told is correct up to 3 decimal places, right? Corrected to 3 decimal places. So after the decimal here we are having 201. So here also after the decimal for x4 we are having 201, and these x values are our approximate root values, right? So therefore what we can say, therefore approximate root corrected to 3 decimal places is, that is 0.201. Okay, so this is how we find the value of x using the secant method. So let me take another example on this. So let me take another example on this. We will see one more example on the to find the roots of a given equation using the secant method. Okay. Second example, find the root, find the root of the equation x e to the power x is equals to x e to the power x equals to cos x using the secant method, using the secant method corrected to 4 decimal places, corrected to 4 decimal places. Okay, first we need to check whether the given equation is in the form of f of x is equals to 0 or no, right? So this equation you can check here, is it in the f of x is equals to 0 format? No, it's not in the f of x is equals to 0. What we have here, x e to the power x equals to cos x. So equals to cos x is there equal to what we should have? We should have that equals to 0, right? So we should have that equals to 0, but here we are having equals to some other value. So to what we have to do, first thing is we need to convert this given equation in the form of f of x is equals to 0. Okay, so how do I convert this? So either bring this term on RHS or bring this term on LHS. Both the ways are fine. So what I will do, I will bring this term on the RHS, so I will get there 0. Okay, so let my f of x be cos x minus x e to the power x. Okay, now what we need to find, directly we can't go for the formula, we can't apply the formula. So what we need to do here, first thing is we have to find the value of x naught and x1, that is interval values we have to find. First interval, first value what we get, that is the x naught, second what we get is the x1, right? So just go on substituting some random values, say I'll put here 0. So cos 0 minus 0 into e to the power 0. Okay. See, whenever we are doing, first thing make sure that our calci is in radians form. So it's not in the radians form. First thing we have to convert this into the radians form. Okay. So now you can see I got my calci in terms of radians form, because always uh, until and unless they give in the question that consider the degree, you should consider these x values, trigonometric function values, as radians only. So we have cos 0 minus 0, that is 1. So here we get value as 1. Now f of 1, that is cos 1 minus 1 into e to the power 1. So how much we get? Minus 2.17798. Okay. So you can observe here, this is positive value and this is negative value. One value we got here the positive and another value we got here the negative value, right? So I can stop here. I can consider this as x naught and this as x1. So what all things we got here? X naught as 0 and x1 as 1. Then what is the value of f of x naught? That is f of x naught in the sense When you put this x naught 0 value in this equation, what is the value you got here? That is 1. So that is my f of x naught. And then f of x1, when I put 1 in this, what I got? That is this one. So that is my f of x1 minus 2.17798 is my f of x1. Now use the secant method formula. Applying secant formula, that is applying the secant method formula. What is the general format of the formula? That is xn plus 1 equals to xn minus 1 f of xn minus xn f of xn minus 1 divided by f of xn minus f of xn minus 1. We should not forget this formula. Okay. Now next is, we know x naught, we know x1. Next is we have to find the x2, right? So x2. So first derive the formula for x2. N value will always start from 1, right? It should be greater than 1, 2, like this. Now substitute 1 in this, 1 plus 1 is 2. Similarly for here, 1 minus 1 is 0. So x naught, f of x n is 1. So 1 minus n is 1, x1, f of n is 1, 1 minus 1 is 0. Okay, so divided by xn, that is f of 1 minus f of x naught. Okay, so now for this, to find the value of x2, substitute the corresponding values. X naught is 0, 0 into f of x1 is this one, that is minus 2.17798 minus x1 is 1. 1 into f of x naught is 1, that is 1. Then divided by f of x1 is this one, minus 2.17798, then minus f of x naught is 1, right? So substitute and get the value of x2. 0 into anything is 0, minus 1 into 1 is 1. So 0 minus 1 is 1. So 0 minus 1 divided by minus 2.17798 minus 1. X2 value, how much we are getting here? 0.314665. So we can write here 0.314665. Okay. Now similarly find the f of x2. Put this x2 value in this equation. So that is cos this value 0.314665 minus 0.314665 into e to the power 0.314665. So f of x2 value, how much we are getting? 0.519872. 0.519872. Now we have x1, x2 and f of x2 also. Next is we need to find the x3. So derive the formula for x3. It's simple. See, instead of every time putting the value in this, you can observe here what we are having. See, if one number is there, minus one number, that will be our f of term. Okay, less than this number will be, one number will be, that is f of term. And less than this term, less than one value for this x will be this x term, right? So now For this x3, what I can write? x1 f of x2 minus x1 f of minus x2 f of x1 divided by f of x2 minus f of x1. Okay. Now substitute the corresponding values. What is x1 is 1. What is f of x2? This one, 0.519872 minus x2 is this one, 0.314665 into f of x1 is this value, that is minus 2.17798. So divided by f of x2 is this one, 0.519872 minus of f of x1 is this one, that is minus 2.17798, right? So substitute in the formula, that is substituted, calculate. So what we will get there? So let me do 1 into 0.519872 minus 0.314665 into minus 2.17798 divided by 0.519872 minus of minus 2.17798. Next value of x, that is the value of x3. How much you are getting? This much, that is 0.446728. Okay, this is our x3. Now find the f of x3, that is substituted this value in this equation, that is cos 0.446728 minus x3 is this value, right? This one, 0.446728 into e to the power x again, that is same value, 0.446728. For the x2 value, we have this much, 0.203545. Okay, next. Correct up to 4 decimal places. See, x2 is 0.5 something and x3 is 0.4 something. Since decimal places after the decimal digits are not same, still we need to carry out this. Next is to find the x4. To find the x4, first derive the formula, that will be x2. To find x4, put x value as 3 in this. 3 plus 1 you will get 4. So x4 is nothing but x2 into f of x3 minus x3 into f of x2 divided by f of x3 minus f of x2. Substitute the corresponding values. What is the value of x2? x2 is this one, that is 0.314665 into f of x3 is, just now we got 0.203545 minus x3 is this one, 0.446728 into f of x2, this value 0.519872 divided by f of x3, this one 0.203545 minus f of x2 is this one 0.519872. So substitute all these values in the calculator, and if you find, you will get the value of x4 as 0.531706. Okay, now find the f of x4. So we have x4 as 0. So what is the given equation is cos x minus x into e to the power x. So cos, what we got here, x4 value 0.531706 minus 0.531706 into e to the power same. Okay, so this is my f of x4. How much I got f of x4? That is 0.0 minus 0.042931. Okay, now again check. So after the decimal, x3 and x4 is 0.531 and x3 is 0.44. Still after the decimal, 1.1 digit is also not same. So again we need to continue this. Okay. So now whatever we have got, whatever all things required, x3, x4 required, right? So x3, how much we have found out? x3 value we have got as 0.446728, and similarly f of x3 we have got 0.203545. x4 just now we got 0.531706, and f of x4 we got minus 0.042931. Now next is we have to find the x5. Okay, so formula is x3 f of x2, sorry, f of x4 minus x4 f of x3 divided by f of x4 minus f of x3, right? So substitute in this, what is x3? 0.446728 into f of x4 is minus 0.042931. Okay, then minus x4 is 0.531706 into f of x3 0.020345 divided by f of x4 is this one, that is 0.531706 minus of minus 0.042931. Okay, now if you take the calc and calculate the value for this, so then we will get the x5 as 0.516904. Okay, and then f of x5, substitute this value in the equation, that is in this equation our this cos x minus x e to the power x. So if you substitute in this equation the value of x for this, then we will get there f of x5 as 0.002594. Next is still, see here x5 is 0.51, x4 is 0.53, only one digit is same. Second and third digits are not same still. Okay, so we need to carry out still the steps. that is x6 we have to find, that is x4 f of x5 minus x5 f of x4 divided by f of x5 minus f of x4. Okay, so substitute the values. X4 is 0.531706, 0.531706 into f of x5 is, just now we got 0.002594 minus x5 is how much? This one, 0.516904 into f of x4 is, so 0.531706. So that is f of that is x4. F of x4 is minus 0.04299315. So divided by f of x5, 0.002594 minus f of x4 minus of 0.04299315, right? So now if you take the calci and do this substitute like this, and if you calculate, you will get the x6 as 0.517747. Substitute this in the equation, that is cos x minus x into e to the power x, like cos 0.517747 minus 0.517747 into e to the power 0.517747. So you will get there how much? F of x6 as, so you will get f of x is as 0.000315. Now check here again after the decimal. After the decimal, what they have told? Correct up to 4 decimal places. You can see correct up to 4 decimal places. So now here x5 is 0.516. So here we have 0.517. Only 2 digits are same. So third and 4 is not same still. So again we have to find out the next value, that is x7. That is formula will be x5 f of x6 minus x6 f of x5 divided by x6 minus f of x6 minus f of x5. So substitute the values. x5 is this one, 0.516904 into f of x6 we have found here is 0.00000315 minus x6 is 0. Sorry, this is x6 is 0.517747 into f of x5 is, so that is 0.002594. Okay, and then divided by f of x6 is this one, 0.000315 minus 0.002594. So if you calculate, then you will get x7 as 0.517757. Now you can see here x6 we got as this value, x7 we got as this value. What they have told, after the decimal point correct up to 4 decimal places. You can see correct up to, see, up to 4 decimal places we need to correct this. So x6 what we have, 0.5177. So here also 0.5177. So after the decimal 4 digits are same. So here also after the digits 4 digits are same for the last 2 iterations, that is x6 and x7. So therefore what we can say here, the approximate root, so therefore the approximate root, corrected to 4 decimal places of accuracy is how much? That is 0.5177. All right. So this is what the approximate root value for the given equation, that is cos x minus x e to the power x. So this is another previous problem we have solved in this video. And yes, so this is how we find the values of the approximate root value for any given equation using the secant method. Okay, then some more problems I'll be solving in my next YouTube videos. Okay.